This is a video lesson for Chapter 13, Section 2 for regression equations Q to Q. We're not going to be talking about slope now, we're going to be talking about prediction. So in 13-1, we would have an equation that had a slope, b sub 1. That's the middle line. But as we know, that slope could be a little higher or could be a little lower. So we made a confidence interval to estimate where that slope would go from here to here, as low as this, as high as this. Well, in 13-2, we're going to be tracking predictions. Now we know that from earlier this year, when I make a prediction, the point on the line, what my equation gives me, we called y hat, the predicted value. But the actual value from the scatter plot, we called y. And the difference between those were the residuals. And we can calculate typical residual size, how far away we expect the points to be. Well, what we're going to do in this section is we're going to take a predicted value. So let's pretend that, for instance, I'm tracking where x equals 5. When x equals 5, my line predicts y will be 14. But again, because the slope could be a little higher or a little lower, that means my prediction could be off. It could be a little higher, or it could be a little bit lower. So we're going to track two different intervals. First one is a prediction interval. This is for individual responses, and we'll get to this formula in a moment. The second is a confidence interval. This is for the mean of the responses, and it's the same formula, only it's the square root of n, s divided by the square root of n, which dividing by a number would make the interval narrower. Now what's the difference? A prediction interval is for individuals. For instance, let's say that we predicted for a, let's say a 67-inch tall man. The prediction came out as 155 pounds. So my equation would predict that a 67-inch tall male would weigh 155 pounds. It wouldn't be too surprising to see a male that maybe weighs 95, that might be on the very edge, maybe 3 standard deviations away, so it's getting out there. But could have one individual this low or one individual this high. So it wouldn't be surprising to see an individual male, one male, be as low or as high as this. So the PI tracks individual scores using the typical residual size. So this is going to be much wider. But if I look at the mean responses, let's say once again that I have a prediction of 155, would I be shocked to see the mean of all of them be 180? And actually, yes, I would, because what we're talking about is all of them. So every single 67-inch tall male, if I averaged their weights, would come out to 180. That's really far away from my predicted. That would be surprising. That wouldn't be surprising for one individual, but it would be surprising for the mean of all of them. In fact, maybe the mean of all of them would only go from 149 to 161. And I'm just making this up, but would that be unreasonable for a mean? No. Anything higher than this, that's getting too far away. So the prediction interval, one individual, this could be a much wider interval because one individual's weight can vary greatly. But the mean of every person who is that tall, their weight on average, that's going to be much narrower. Let's talk about these formulas briefly. Y hat is the predicted. So when I plug x into my equation, the y hat value that I get is my predicted response. That goes in here. Plus or minus, here's my t-score, which again, if the sample size is large enough, will be the same as z. This is just s. This is s divided by the square root of n, because this is going to be much more narrow. S here is the typical residual size, which makes sense, because if we're tracking how far away we could be off by, so here's my predicted response, I could be this high or this low below that. Talking about the typical residual size, how far away do we expect to be? Typically, how far away should these points be off by? So that typical residual size is going to be our spread. y hat is going to be our center or point estimate, because that's the point that's on the line in the center of the data. All right, let's do our example. We tracked 196 college-age males, big sample size, probably going to be using z-score here. We tracked their heights and weights. Here's our equation, comparing height and weight. Here it is with notation. Typical residual size, 29.6. So the first thing we're going to do is we need to find the average weight for a 71-inch tall college-age male. So if we're tracking college-age males, what does my equation predict their weight should be? So when I take the equation and plug 71 in for x, it predicts 172.68 pounds. So on average, that's what I would expect an individual that tall to be. But we know there's some room for error. It could be a little higher, a little lower. So the next question says, at a 95% confidence level, make an interval in conclusion about the true weight of one individual 71-inch tall college male. So because we're doing it for one individual, we're going to do the prediction interval, which takes my prediction for 71-inch tall males, plus or minus t, which would be 2 here because the sample size is big enough, it's the same as z, times the spread. And the spread is the typical residual size, how far we expect the points to be off by. When I run that, I get this interval, which means that I'm 95% confident that one single 71-inch tall male would weigh between this and this. Pretty big spread, but that wouldn't be unreasonable for one male to be that skinny or to weigh that much. Now we're going to do a 95% confidence level. We're going to make an interval and conclusion for the true average weight of all, the mean weight of all of them. So we're doing it for every single college-age male who's 71 inches tall. So what I'm going to take is a confidence interval, because we're doing it for the mean for all of them, not just one individual. The confidence interval takes my prediction, once again, plus or minus the t-score 2, and it's going to be the typical residual size divided by the square root of n. N is 196, the square root of 196 is 14. So s divided by the square root of n. Run those numbers. Now we get a much narrower interval. So I'm 95% confident that all 71-inch tall males would have an average weight between, and again, all of them would have an average weight between this and this. Watch your wording. Or an individual, would weigh between this and this. The average for all of them would weigh between this and this, is how we word a confidence interval. Last thing, let's just see what would happen. What if the sample came from 11 people instead of 196? What would change in our formulas? Well, that's not changing all of these, supposedly. We're going to assume that the typical residual size and everything ends up staying the same. What would change is the degrees of freedom. So now it would be n minus 2, which is 9. Degrees of freedom is much smaller. I would look up in the chart in the back of the book. This is t-score. So instead of using 2, since my sample size is not big anymore, I would use the t-score that matches the degrees of freedom of 9, which is 2.262. Make sure you get on and complete the assignment, and have a great weekend.